take a quick look at some composition of trig and inverse trig functions. Up on the board I've got 3 problems here, and you'll notice the trig and the inverse trig function always match. So it's cosine paired with an arc cosine, tangent paired with an arc tangent, actually in both directions here. Okay. We'll look in the next video at what happens if I compose, let's say, sine with inverse cosine, so that the trig and the inverse trig don't match, but we can still actually evaluate that. It's tempting here to say, oh, cosine and arc cosine are inverse functions, so they just undo each other. And tangent and arctan are inverse functions, so they undo each other, and just blindly say 3 pi over 4, 3 pi over 4, 5. We would get 2 out of those 3 questions right. The problem is cosine is not the inverse of arc cosine, and arc cosine is not the inverse of cosine. Remember, we started with cosine and said that's not invertible. And then we restricted the domain, and we said that function is invertible. But that means that arc cosine isn't the inverse of cosine, it's the inverse of cosine with that restricted domain, which means the range of arc cosine is limited. So, if I'm plugging in an angle to cosine, and then I plug that number into arc cosine, I'm only going to get that angle back if that angle was part of the restricted domain of cosine, which then becomes the range of arc cosine. Same thing here with tangent. I'm plugging in an angle. Arctan is only going to give me that angle back if this was in the restricted domain. Now, when we restricted the domain for cosine, remember we always keep quadrant 1. We couldn't keep quadrant 4 because cosine would repeat its positive values there. So for cosine we chose quadrant 2. 3 pi over 4 is in quadrant 2, and it's in the version that's adjacent to quadrant 1, 0 to pi over 2. We restricted the domain to be from 0 to pi. That's there. So here we do get 3 pi over 4. But when we worked with tangent, we kept quadrant 1. We said tangent was negative in both 2 and 4, but we wanted to get a connected piece of graph. So we chose quadrant 4. So the restricted domain of tangent, which becomes the range of arctangent, was from negative pi over 2 to positive pi over 2, and that is not in that interval. So if that's not in that interval, I have to do this as a 2-step process. I would have to say, here's 3 pi over 4. So that's going to be in quadrant 2. In quadrant 2, tangent is negative. The reference angle is pi over 4, so I can attach tangent of pi over 4, which is just 1, because that gives me my 45, 45, 90 triangle. Tangent is opposite over adjacent, and since this is an isosceles triangle, opposite and adjacent are the same. So this becomes arctangent of negative 1, but now I know we're working with an angle in quadrant 4, because that's the quadrant where we take on our negative values for arctan. Now the reference angle will be the same, it'll be pi over 4, and I just need to get that as a negative angle. Remember, we don't rotate around the long way, we rotate in the negative direction. And so this is going to be negative pi over 4. So here they didn't cancel out because this wasn't tangent with the restricted domain. In order to be able to plug in 3 pi over 4, I need to be working with the original tangent, which is defined almost everywhere, just not at odd multiples of pi over 2. Now if I look at this one, when the inverse trig function is what I'm doing first, I'm okay, because I know this will spit out an angle that's in the appropriate interval. I don't have to check that because the definition of arctan guarantees it's going to spit out an angle that's in the appropriate restricted interval. And then when I take tangent of that, I'm just going to get 5. So I don't need to worry about it if the inverse trig function is on the inside. Then it's guaranteed to give me an angle that's in the appropriate interval. And when I take tangent of that angle, I just get that number. Okay. But if the trig function is on the inside, I need to take a look at what I'm plugging into that. If I'm plugging in a number that's not in the restricted domain, then I'm not working with the version of the trig function that's whose inverse is the arctan or arc cosine that I have on the outside. So just something to be very, very cautious about as you're working with these function compositions.